What if one machine could show us the universe like we've never seen it before? That's exactly what the Vera C Rubin Observatory in Chile is doing, and it's blowing minds left and right. In its first months of 2025, it caught 2,000 asteroids in a single night, revealed galaxies from the dawn of time, and started unraveling mysteries like dark energy that we barely grasp. This telescope, perched in the Andes, isn't just looking. It's filming the cosmos with a 3.2 gigapixel camera that captures 50 full moons in one go. It's like giving the stars a high-def live stream. So, come along as we uncover what this cosmic game-changer is revealing about our place in the stars. So, how does this stellar live stream work? You might think a telescope is just a fancy tube for spying on stars. But the Vera C Rubin Observatory laughs at that idea. Unlike Hubble, which squints at a patch smaller than a grain of sand held at arm's length, or the Very Large Array's radio dishes tuning into invisible wavelengths, this observatory throws open a stellar gateway. Its 8.4-meter telescope, paired with the largest digital camera ever built, 3.2 gigapixels, weighing 6,000 pounds, captures a 3.5-degree field, spanning 50 full moons in one shot. That's 100 times wider than Hubble's view and broader than the VLA's narrow focus. Most telescopes take static snapshots, waiting days or weeks to revisit a spot. The Rubin scans the entire southern sky every 3 nights, crafting a high-definition movie of the heavens. Its 3-mirror design sharpens every detail, from nearby asteroids to distant quasars. Born from the 2010 Decadal Survey, where astrophysicists charted science's next leaps, it's funded by the National Science Foundation, Department of Energy, and visionaries like Charles Simonyi and Bill Gates. This isn't just a tool, it's built to catch what others miss. So, what did it capture when it powered up? In April 2025, the Vera Rubin Observatory flicked on its spotlight, and by June, it dropped images that had astronomers gasping. Picture the Virgo cluster, a chaotic swirl of 10 million galaxies, some colliding in fiery mergers, others glowing faintly from the cosmos's edge, billions of light-years away. Then there were the Trifid and Lagoon nebulae, vibrant clouds of gas and dust shimmering in pinks and purples, like stellar nurseries where stars are born. But the real jaw-dropper? In just 10 hours, it caught 2,104 asteroids zipping across the sky, rocks no one knew existed, weaving through stellar chaos. That's a month's worth of discoveries for most telescopes, nabbed in less than a day. Unlike Hubble's painstaking mosaics or the VLA's radio maps, these images are instant wide-angle revelations, showcasing the Rubin's unmatched speed and scope. They're not just pretty. They're proof this machine sees the heavens like nothing else. But what's fueling this stellar powerhouse? Let's dive into the cosmos's biggest mystery, dark matter. You can't see it, touch it, or smell it, but it's out there, holding galaxies together like invisible glue. Think of it as a stellar scaffold, shaping the cosmos's structure without showing its face. The Vera Rubin Observatory is built to hunt it down. By mapping billions of galaxies, it traces how they clump and cluster, revealing where dark matter hides. It's like finding a ghost by watching how it moves the furniture. In its first 25 images, it's spotting galaxy patterns that hint at dark matter's grip, patterns Hubble's narrow view or the VLA's radio focus couldn't catch at this scale. Dark matter makes up 27% of the cosmos, yet we barely understand it. The Rubin's data, processed automatically to handle a flood of 20 terabytes a night, could crack the code, showing what's pulling the strings behind the stellar curtain. But there's another mystery it's chasing, and it's even wilder. If dark matter is the cosmos's glue, dark energy is its rocket fuel, and it's way more baffling. Making up 68% of everything, this invisible force pushes galaxies apart, speeding up the universe's expansion like someone's flooring the gas pedal. Scientists don't know what it is, but the Vera Rubin Observatory is hot on its trail. Every night it tracks how galaxies move, building a cosmic growth chart. Unlike Hubble, which studies distant galaxies one at a time, or the VLA, which skips optical light. The Rubin's wide-field scans capture thousands of galaxies at once, revealing expansion patterns in real time. Its early 2025 data shows galaxies racing away faster than expected, hinting dark energy might be stranger than we thought. Picture the universe as a balloon, inflating faster and faster. This telescope measures every stretch. If it finds clues to dark energy's nature, it could rewrite physics. But it's also keeping an eye on our own backyard. Asteroids. They're the stellar bullies of our solar system, and some could ruin Earth's day if they get too close. The Vera Rubin Observatory is like a galactic security camera, catching them in the act. In its first 10 hours, it found 2,104 new asteroids, including 7 near-Earth objects that could cross our path. Most telescopes find tens of thousands annually. The Rubin nabbed a month's worth in one night, from just one sky patch. While Hubble might spot a single asteroid in a narrow frame, and the VLA doesn't see them at all, the Rubin's rapid scans catch thousands in motion, checking the sky every few hours to track changes others miss. Over the next decade, it's set to catalogue millions, building the most detailed solar system map ever. NASA's watching, because these rocks aren't just science, they're potential threats. By tracking them, the Rubin could save Earth from a stellar collision, but it's also rewriting our cosmic story. Here's where things get epic. The Vera Rubin Observatory isn't just snapping photos. It's running a 10-year project called the Legacy Survey of Space and Time. Picture a time-lapse movie of the heavens, cataloguing 40 billion objects, 20 billion galaxies, 17 billion stars, and millions of asteroids and comets. That's more than every optical telescope in history combined. Each night, it generates 20 terabytes of data, enough to overwhelm your laptop 1,000 times over, turning pixels into discoveries faster than you can say supernova. Unlike telescopes that revisit the sky weekly or monthly, the Rubin checks every few hours, catching fleeting events like stars exploding or comets streaking. Hubble's deep but narrow views, or the VLA's radio signals, can't match this speed or scale. This survey is a front-row seat to the greatest show in the cosmos. And the best part, you don't need a VIP pass to join in. Think science is just for lab coats and PhDs. Think again. The Vera Rubin Observatory is throwing open its doors, making all its data public. That means you, yes you, can dive into 20 terabytes of stellar goodies every night. Want to hunt for a supernova that just went boom? Or spot an asteroid no one's named yet? All you need is a computer and curiosity. Scientists are building tools to make this data accessible, turning regular folks into citizen scientists. Unlike past projects where astronomers hogged the telescope, the Rubin's open pipeline, born from the Decadal Survey's vision of shared science, lets anyone explore. Imagine a kid in their bedroom, or a retiree with a laptop finding something that stumps the pros. It's happened before. Amateurs have discovered comets and stars, and now the stakes are higher. This telescope is making us all explorers. But what else might it uncover? Now, let's get a little wild. What if this telescope finds something no one expected? Scientists are whispering about a 9th planet, a shadowy world lurking beyond Neptune. The Rubin's deep, wide scans could spot it within a year, solving a decades-old puzzle. Then there's the chance of catching interstellar visitors. Objects like Oumuamua, that odd space cigar from 2017 that zipped through our system. Unlike Hubble's slow targeted shots or the VLA's non-visual data, the Rubin's rapid sweeps might catch another. And here's the one that'll keep you up at night. What if it detects something bizarre, like a signal from an advanced civilization? No one's betting on alien tech, but its knack for spotting fleeting events sparks serious what-ifs. These possibilities, however out there, remind us the cosmos loves to surprise us. And behind this galactic quest is a name worth remembering. This telescope isn't just a machine, it's a legacy, named for Vera Rubin, who proved dark matter's existence. In the 1970s, She showed galaxies spin too fast for the matter we see, rewriting our stellar playbook. Facing skepticism as a woman in a male-dominated field, her work reshaped astronomy. Naming this observatory after her, chosen through the Decadal Survey's rigorous process, is a promise to keep chasing the unknown. With the funding and support it has, it's humanity's bet on discovery. Unlike Hubble's focused legacy or the VLA's radio niche, the Rubin's vast scope maps our place in the grand stellar story. Every image, asteroid and galaxy brings us closer to why we're here, and that's a story worth telling. So, here we are, standing on the edge of the unknown, with the Vera C. Rubin Observatory as our guide. It's catching asteroids that could save Earth, unraveling dark matter and energy, and inviting us all to explore the heavens. In its first months, it's shown galaxies, nebulae, and space rocks we never knew existed. Over the next decade, it'll catalogue more than all telescopes before it, painting a cosmos that's alive, dynamic, and full of surprises. But here's the real question. What's out there we haven't imagined? As this telescope scans the skies, it's not just finding answers, it's sparking questions that could change everything. So, tell me, what do you think it'll find next? Because if this is just the beginning, the universe is about to get a whole lot wilder.